This is regarding for the B2C commerce technical report and the dashboard. So this is the scenarios we can see. Let's start by discussing a common challenge for the developer face. So there is a wide variety of development. See, the developer needs insight into the back and technical aspect of site performance, which is also impact the customer experience also. This insight includes overall DROM performance matrix, site specific matrix, and even more granular controller level of matrix. Me, Nadia, so she's an IT manager at Northern Trial Outfitter. So this is the scenario we are looking. So who needs to make an some performance upcoming sales event, and today she needs to look for a way to improve the performance in preparation for peak promotions. She also want to audit the site for potential existing issues. um, as a developer, she wants to find the opportunities to optimize her controllers and performance metrics by spotting unusual patterns and investigating them. Um, let's dive into some technical reports, and we can review some metrics such as catch some performance also. So this is the one you are looking for, the technical report. Here is an example for reports that are available for some users. Comparing data such as the controller average response time against a real-time system workload can reveal patterns in inside performance that leads to optimization opportunity. Um, before we can dive in for deeper, so let's review some terminology. So OCAPIA stands for Open Commerce API. Um, OCAPIA enables you to access the resources using HTTP requests and responses. It's called the Salesforce APIs use our ROM resource and recorded technical reports also. So Escape or Salesforce Commerce API is another API which was designed with a focus on accelerating the implementation of headless architecture. While you can accomplish many of the same tasks with either Acapia or Scapi, there is a complete future parity between those two. They are separated in our technical reports also. Controller we are gonna use as a generic term. The data the same for customers using pipelines. SF array or JavaScript controllers. Lastly, we have several site caching, which is the temporary storing of web files and data on an origin server for reuse. It's important to emphasize that caching matrix pulled from our technical reports and dashboard represents caching on a server. and not catching done locally in a user's web browser. Catch matrix pulled from front-end auditing tools such as Google Page Speed, Insights, or Web Page Test org. Typically refer to caching from the browser representative. Okay. So now that we are on the same page, we can dive into the technical controller report dashboard. In this view, we will find insights about the server side technical operation data. Specific reports include average response time for all controllers and requests, catch hit ratio for controllers or request, non 200 level response round wide, um, a response time distribution chart for a different representative on a response time, and the table of main controller requests also with the controller level performance matrix. The technical Okapi and SCAPI dashboard are similar to the controller report dashboard. We can find average response time, a request report, and non 200 level response, a graph for response time distributions, and names of requests with API versions number. We can work with some technical report. We can begin with some controller reports. So controller report average response times report, response optimization. The control average response time report shows the trend of average response time per request in milliseconds. We can view controller response time aggregated ROM wide, or focus on a single controller on a specific site. There are many variables that impact controller performance, but response time often increases in a high traffic. During the periods and high traffic, it's always a good practice to compare spikes and average response time, the spike and amount of request to determine if an increase in traffic is the culture corporate. Regardless of controllers can be optimized to reduce the impact of higher traffic on their performance. In general, we wanna pinpoint controllers with average response time of about 200 milliseconds. But benchmarks for controllers vary. Depends on the purpose of the controller. Uh, can... Speaking of benchmarks, here are some performance benchmark for B2C commerce sites. For each storefront experience, the recommendation for desired range in milliseconds and cache content percentage vary. For example, the home page experience, which would represent the home show controller and SFRA, is expected to take between 100 milliseconds and 250 milliseconds to return a response once the controllers call. It's also expected to pull over 90% of the content from cache on average. Uh, Product search and product details experience are expected to perform within 250 milliseconds and 500 milliseconds, with over 60% of the content pulled from cache. These metrics change due to the expected functionality of the experience. When we get into the chart of checkout matrix, you will notice that desired range in milliseconds increase. This is to account for a typical checkout experience, which involves more calls to third parties, for things such as address verifications, tax calculations, and more. Third parties can impact your performance metrics dramatically. So it's important to keep this integration optimized and to try to follow within this recommended response time. For this controller, we don't provide cache content recommendations. This is because we have access to sensitive customer data, and we shouldn't be catching all of this information. Finally, we see an entry for all other experience, and ensuring any customer's calls fall below 500 milliseconds and are pulling at least 70% of the content from catcher. It's a good rule of thumb, but use good judgment to compare your experience to other location of the site. For example, a largely static merchandise pages should perform closer to the home page matrix. And while a custom product listing page should meet the category listing page matrix above. So this is the example first on the sales user. This is the average response, and the graph plot a point representing the average response time in milliseconds for each day in the time frame selected. To see response time, she can hover over the plot line, and we could show you. She remembers that May 19th, 2022, uh, the site ran similar promotions which caused a performance spike. She can pinpoint the controllers with the heaviest workloaders during this time period to focus her effort to optimize the site for her next campaign. So now, Janelle, move to on the catch hit ratio report. It displayed the average amount of data that the controller pulls from the catcher, represented by the blue line. She knows that overall Her side catch hit percentage should be 70% or higher. So catch is being severely underutilized. And she makes sure to also look into the green line that represent catch, miss, and store. Catch, miss, and store represent the amount of content that's stored to catch rather than pulled from catch. She says catch, miss, and store is 3.72%, and with this matrix significantly is lower than per catch hit percentage. She can see that her controllers are not effectively storing to catch. This is when Nadia researched catching strategies. She started with catching strategies for B2C white paper and find several common causes for high catch miss. And in her cases, it's like that there have been customization done with the catch considered in her controller. She should ensure that catching is included either in her ISML templates through the sketch tag, or preferably she's using a script API to see her catch expression. If she had a higher catch, miss, and store percentage, she prioritized ensuring that the URL parameters aren't causing duplicated catch entries. Through the business manager, she can configure the server to ignore specific URL parameters that would otherwise make the request to appear unique and cost a store a duplicate entry. She would also audit her personalized catching strategies. While personalized catching can improve response time for customers, over personalized catch creates a heavier burden on the server by storing more versions of a page. So it should be used in moderation. The response time distribution graph is a visual representation of how often controllers perform above guidance in 500 millisecond segments. Nadia reviews the graph to see if there is any significant disparity between response time that customers are experiencing. Fortunately for her, most requests are returned below 500 milliseconds as expected. It if half of our customers were experiencing exceptional performance while the other half were experiencing severe performance issue, this could suggest an issue with the controller, such as intermittent service outage or a branch of logic that unoptimized. The non 200 response report display the amount of 300, 400, and 500 status codes from the server. Nadia can see a significant amount of 404 error, signifying that the resource aren't found. These error are represented by a yellow line. Nadia will need an auditor her site for broken lines and missing resources. So far, Nadia used technical reports and dashboards to review her site-wide average response time for a general health check. She identified performance issue with controllers affected most by a previous promotional period. So she pinpointed controllers with optimized catch and leveraged the non 200 level response report to review an issue with 404 error. So let's work with some technical report of Ocapia and Escapia dashboard and reports. This is what the Recoaster report look like for both Ocapia and Escapia. So in this table, you will find a variety of information such as the API type and the version, which resources are being requested, and the method of request such as post, get, and put. You can also find the average response time report, but you will see the catch hit percentage is not included. Server-side catching for API calls happens on the application tier rather than the web tier for both Okape and Escape. For Okape, there are three components API to consider: calls to the data API, which is often used to report order status, can be cached. The Meta API is used to get information about available Okape resource, and the Shopper API is used for storefront like often found in mobile apps. Both of these types of API calls can be cached. So we can see some demo. So this is the report and dashboard technical report. Let's go back to Nadia, how she can show us technical reports and dashboard, make it easier to optimize her site performance. So if you are already got access to technical report and dashboard, you can follow along. So, what we'll be doing over the dashboard, included in the report, we will dive into some of the controller report, and we will take a peek at Okape and Escape report also. So, So Nadia has navigated to her REMS report and dashboard and selected the technical report view. And by default, her data is filtered into 7-day time period. Um, so this is the C7 period. So she increases into the some 30 days for the broader way of performance. She did some update for the broader view. Immediately she can see the average response time ground wide is 108 millisecond, which is the exceptional performance by milliseconds being under 200 millisecond, but her catch hit percentage is 10%, which is severely low. She can see their work done to get her catch hit closer to 70% and optimize her catch. She will further reduce her average response time. Before diving into the controller specific matrix, she'll look in her non 200 report and uh, so we see the 301 redirect are in constraining because her team has redirected for legacy product and but the amount of 404 error is concerning, and she makes a note to audit the site for additional link that need a redirect or to audit for link that were removed because they lead to pages that were no longer live. So Nadia take a look at her main controller, and here she can see which controller are used most often, ranked from top to bottom, which helps her prioritize which controller to start with. She can also download this file as a CSV. So CSV if editing is needed. At a glance, she can see that her home show controller is performing within the 100 to 250 millisecond benchmark. But 65% of that request is missing catch. Moving on her show controller that represent the product listing page. She noticed that its average response time is 440 milliseconds. While it's below the 500 millisecond benchmark, there's room for improvement. She reviews the catch hit percentage at the end of the row and can see catch hit miss and store rate of 48%. She makes a note to review catch strategies for B2C commerce white paper for how to ensure more of the content is pulled from catch rather than stored to catch. Now, Nadia wants to take a deeper look at her Northern Trail Outfitter site specifically because it's the highest traffic site on the ROM by far, and where she will setting up her latest promotion. So in the filter, she will use for the filter by NTO SFRA. Northern Trial average response time site wide is 107 milliseconds with a 100% catch. She focused on date of her last promotion, which is October 4th. Was a uptick in traffic on the site as well as an uptick in average response time. Right here, it's on October 4th. The average response time. She dives deeper into the controller specifically by clicking the link in the main controller request report. On October 4th, the home controller also experienced an uptick in traffic and the average response time. She makes a note to focus on a specific controller because it's only pulling 33% from cache, which is means a higher traffic has a higher impact on his controller performance. You see that right here in 33. If her home show controller was performing slowly, she could dive deeper into included controllers to further isolate any performance issue. Now that Nadia has some insight into how her site perform under the stress of promotion, she decided to take a look at API request. She navigates to Escape Reports view by clicking the tab in the navigation above the report. Nadia can see the amount of API request, unique API version, and unique resource request in that top bar. She can also filter data by API type, method of the request, and by which resource is being used, such as basket, customer, promotion, etc. The average response time for Escape request on her is around 336 millisecond, which is higher than the 107 milliseconds recorded for the controller on the RAM. She knows that because the vector doesn't catch a SAP response, they have higher resource cost than other storefront requests. So higher average response time aren't uncommon, but that doesn't stop her from adding an edit of her API catching strategies to her to-do list. With the information she collected, she feels a lot more confident about where to start with the optimize her promotion. Now, we would like to share some best practice about when to run the report and where to look. Here, there's an examples of when to review the technical report and dashboard. You can use technical report as an additional health check after a code release. Like Nadia, you can run a site performance audit before during or after peak period to monitor traffic and corresponding response time. It's also helpful to keep track of the non 200 level response to ensure functional campaigns. This tool can also be used to troubleshoot any reported site performance issue, whether you need to start with the global health check at the ground level, or you can exactly which controller to look for. Technical reports can help you pinpoint where issue originate. We can call some our key resources. Those are all the key resources you can find. Childhood is a great place to start with access to hands-on training from anywhere, and you can find more information. So thank you for watching. Please like and subscribe. See you next video.